வைத்து அடி போற்றுகின்றேனே.
நமஸ்தேஸ்து மகாமாயே ஸ்ரீபீடே शङ्खचक्रगदाहस्ते महालक्ष्मी नमोस्तुते. नमस्ते गरुडारूढे कोलासुरभयङ्करी सर्वपापहरे देवी महालक्ष्मी नमोस्तुते. सर्वज्ञे भयंकरी सर्वदुःखहरे देवी महालक्ष्मी नमोस्तुते. सिद्धिबुद्धिप्रदे देवी मुक्तिमुक्तिप्रदायिनी मन्त्रमूर्ते सदा देवी महालक्ष्मी
I shower my warm welcome to all the participants on behalf of the Department of Mathematics of Mahalashmi Women's College of Arts and Science. Mahalashmi Women's College of Arts and Science, established in 1997 with an aim of optimizing the potential and competence of the students through critical thinking, academic quests, and extension activities. The institution pursues to proliferate education and transform young women into professionals who further be matured, responsible, and exercise their potential to empower society. With extreme greatness, I greet our respected principal, Dr. Mrs. Booma Ma'am, and the faculty members of Department of Mathematics for providing us this opportunity. A special thanks to the members of the college committee, Thiru S. Kunjudabadam sir, Thiru S.K. Thirukumaran sir, and the management of Mahalashmi Women's College of Arts and Science for constantly providing us the support that we need even in these pandemic times. The Department of Mathematics of Mahalashmi Women's College of Arts and Science renders quality education for undergraduation and post-graduation studies effectively. The students of the Department of Mathematics succeeds well in the Madras University examinations by securing top university ranks and several of them scoring centum in several papers. Math Pirates, a blooming association inaugurated on the 12th of December 2019 by the Department of Mathematics for the enrichment of students to make them excel not only in academics but also in co-curricular activities. Now, may I call S. Aparna of 2nd MSc Mathematics to welcome our guest speaker.
Good afternoon to all. On behalf of Mahalashmi Women's College of Arts and Science, I welcome you all for the webinar. I extend my sincere thanks to the management and principal ma'am for their support and encouragement for organizing this webinar. I extend a warm welcome to our guest speaker, Dr. Mrs. Kalyani Desikan, Professor, Vellore Institute of Technology. She has completed her doctorate in cosmology as a research area at IIT Madras. She is the Dean Academic Research from May 2019 at Vellore Institute of Technology, Chennai. She has a very strong profile with 25 years of teaching experience in academic and worked in most of the reputed colleges of their cities and currently guiding 6 PhD students in the area of data clustering and spectral analysis of graphs. She has published 25 journals in national and international publication. She also has extensive knowledge in computer skills such as MATLAB programming or programming, etc. Dr. Mrs. Kalyani Desikan ma'am has received award like Best Faculty Award Female 2011 and CTS Best Faculty Award 2015 but by VIT Chennai. We are so honored to have you with us, ma'am. We are really awaiting for your insightful session, ma'am. Thank you.
Thank you. We are so glad to welcome our principal, Dr. Mrs. N. Buma ma'am, to address the participants gathered here in this platform.
Yeah, good afternoon, one and all. Actually, a long-awaited intellectual session by Dr. Mrs. Kalyani Desikan for quite some time. So I don't want to take much of my time, but I would like to congratulate the Department of Mathematics of Mahalashmi Women's College and also management for supporting us to organize all these webinars. And especially my special thanks to Mrs. Kalyani, very intellectual person and very simple and down-to-earth person. And she has been like always a pillar of strength to our department, especially of our college, especially Maths department. Thank you so much for accepting. It's a very, she is very, we are very, blessed to have her because I think more than 1 or 2 months we were waiting for her appointment, and we are precious now today. Thank you so much, waiting for you. Thank you.
Thank you, ma'am. Taking our evening further and to begin with the session, I, on behalf of everyone present here, heartily welcome our guest speaker, Dr. Mrs. Kalyani Desikan ma'am. Just a reminder for the participants, please be sure to type your questions in the chat box. Your doubts will be clarified after the lecture. I now hand over the session to the speaker. Over to you, ma'am. The session is yours.
Okay, thank you so much for those warm words. Okay, at the outset, I would like to thank the organizers and the management of Mahalashmi Women's College for having invited me. And as was pointed out by Dr. Buma, Mahalashmi College is not new to me. I have visited the college, and I have a special affinity because they are doing a lot towards taking it to the people who most need education. All right, so that is a very inspiring thing for anybody. So I'm sure the college would grow, and with the support of your management, I'm sure you can go places. All right. So I would like to thank the mathematics department for inviting me again. All right. And I still remember the last time when I came there. It was after a heavy downpour. I had come to Mahalashmi College. But in spite of all the trouble, we could manage the show very well. All right, so that shows the grit and the determination of the people there to get things done. Okay, so without taking some more time on these things, I'm truly thankful to all of you for having invited me. And I mean, I'm not a very busy person, but right now my role is such that it has become busy. That's it. Okay, so I'm available for all of you through mail and other things if you do want to contact me. All right, so I will start off with my presentation, and you must be wondering, this is a talk for a mathematics department, and I have chosen a topic called data clustering. All right, so it's not just because it is my area of research. It's because you must see that mathematics is not just abstract. Okay, people should appreciate that mathematics can be applied, and it is very much needed, especially for the students. The youngsters who are here, I would like to look at math. I would ask you to look at mathematics as a way to, I mean, wherever possible, you can apply mathematics. Okay, that's the passion with which mathematics should be looked at. Right. So, without taking some more time on this thing, I would start sharing my screen. And as was pointed out, you can post your questions in the chat box. I will try to answer as many as I can today. And if it's not possible to do it within today, you can even mail it to me if you're interested. Right. Okay, I think my screen is shared.
Yes, ma'am.
Okay. So as I had mentioned, the topic that I had chosen for today's discussion is data clustering, and I'm just going to give you an overview of it. And I want the people in mathematics or other fields to look at how you can apply the mathematics to an area which is so in vogue today, right? Anybody you see, you would be talking about data, big data, data analytics, data science, so many terminologies, okay? And data clustering is probably a little part of it, all right? So moving on, this is going to be the journey today. Looks big, but it is actually not that big. I will take you through this very, very quickly. So we'll be looking at all this. So what is knowledge discovery? Why we need data mining? What do you mean by supervised and unsupervised learning? What is clustering actually? And the next concept that I've mentioned is distance measures. And that's something where the mathematics is going to come into play. So for the students, I would like to draw your attention to these things, such as distance measures. I'll come to that. When we come to those particular slides, you must see how mathematics is used, especially in an area such as data science or data analytics. And obviously that topic that I'm going to talk on is clustering. There are various approaches to clustering, right? There is something known as partitional approach or a hierarchical approach. And what I would be discussing today is the first of the approaches, which is the partitional based approach. Okay, so that is the first one that we will be looking at. And K-means algorithm is a particular, very famous algorithm, which falls under the class of partitional approach. Okay, so that we'll be touching upon. Especially this talk is purely aimed at people who are just in their graduation or PG or getting into research. You can look at it as a nice field where you can apply mathematics to it. And last one, of course, I'm going to talk about clustering. Clustering is nothing but grouping of items. So I've grouped the items. How sure am I? Have I done it correctly or not? You go and do a validation. Okay. So this is how the roadmap is going to be. It looks long, but I won't take too much of the time. I will stick to the time limit. All right. So if you look at the knowledge discovery as a process, right, it's a very simple process. And I do not know, probably some of you already have come across such a thing. All right. So what happens is we start off with what is known as a raw data which has not undergone any process. Okay. I mean, as a matter of fact, right now we are producing data. Data is the videos being streamed. That is the data, right? So that is raw data. And then basically you need to know how to store it. Okay. So you need to have something, a warehouse or a database where you store all the data. And after that, after storing, what you need to do is you just can't work with it directly. You need to do what is known as selection and cleaning. So the raw data comes in, you store the data, then you go ahead with the selection and cleaning of data. And at that point in time, what you get is known as a target data. All right. So with this target data, again, you can do a lot more things because it is just cleaned and it is ready for use. But we have to bring it to a state where it is usable. So what you do is you do what is known as a data transformation. You do that. So at the end of it, what you get is the transformed data. So till this thing, it is what we call in data mining as the pre-processing stages of data mining. All right. So the data is first obtained, then you store it, then you clean it, then you transform it, and then you have the transformed data. So after that is where the task really begins. So you're going to do what is known as data mining. And the clustering that I'm talking about is one very small part of data mining. All right. So when you do these activities, it could be that I'll come to the different activities which are there under data mining. So after you do any of those tasks, what you basically will find is some patterns in your data, some rules. Okay, this is what data analysts do day in and day out. Okay, they identify patterns, they identify the rules, they identify the connections between the various data. So this is the real beauty. You start off with raw data and you reach a stage where you've identified some pattern. All right, and based on that pattern, you're trying to interpret it and evaluate the pattern. You basically do that. At the end of it, what you're going to get is knowledge. Okay. So, and the cycle goes on. So at the end of it, probably if the knowledge thing is good, you're going to have a very good understanding. Right. So this is the entire knowledge discovery process. Right. Okay. So I hope we have understood it pretty well. So this is a very famous diagrammatic representation of the knowledge discovery process. You take any book on data mining, probably a similar kind of diagram would be there. Now moving on. So why do we talk about data mining now? May I request the audience to mute, please? All right. Okay. So why do we need to look at data mining? Okay. The reason is right now data is being produced at a phenomenal rate. Okay. Like I said, right now, this lecture is being streamed. Like that, there could be thousands of lectures being streamed. All right. And each one of us is using a mobile phone. Okay. every bit of thing. There is a, you exchange through WhatsApp, you exchange through various other means, SMS, whatever it is. So it is exchanges going on. So that is data is being produced at a extraordinary rate. All right. And then comes, now this is not enough. If the data is growing, we should know how to store it. Okay. Earlier, there was a difficulty. I do not know, many of your youngsters, before my PhD days, even before my PhD days, if I want to store some data, and if you look at any server, it will be occupying one entire floor of a building. Okay, so you need that huge machines, and that too, after that, you can store only minimal data, probably just KBs or MBs. Okay, now it has grown, the ability to store has grown. Okay, so there's one more reason why data mining is really looking. First thing is data is growing. Next thing is we have the ability to store it now. And right, so nowadays, so since all this has happened, we look out for more and more. We want real sophisticated information, right? So these are the primary reasons, and how I'm going to do it, I will uncover the hidden information. Okay, when we saw the previous slide, we are talking about patterns and the connections which are there. That is what you're going to uncover from the existing data. So that becomes, you're going to uncover the information or knowledge there. And so you're going to have data mining. So that is the real reason. Okay. Now, this particular slide, probably I would have used in different talks and a different context. Okay. So, but I would like to draw your attention. Just, I said that data mining is the process of discovering knowledge or patterns from huge, massive amounts of data. You can uncover the knowledge. Okay. So that is what it is. But what a beautiful analogy that we have here. Okay. So this mining, the one on the top, we know already. There is rock. From the rock, you can mine gold. What do we do for that? We make use of tools. And who does it? The miners. All right. So this is an age-old thing where if you talk about gold or any kind of mining, this is what happens. Now look at our age now. Look at the knowledge age. Okay. So what we have the raw data. And then what are we going to ultimately get out of it? The knowledge. Who's going? How are we going to do it? We have our software, the algorithms, the models. Then who will do it? The analyst. You call them as data analysts, you call them as business analysts, you call them as data scientists, whatever it is. So such a beautiful analogy. I think it will really stay with all of us. Okay, if you want to tell somebody what it is, you know that data mining, even if you don't understand if you don't appreciate the full talk, I wouldn't say not understand. All right, even if you don't appreciate the entire talk, if somebody says, okay, you listen to a talk, what can you say about it? Okay. You can probably say, I know what is data mining. Data mining is I get knowledge from the data. For that, what do? I make use of the software tools. And then who does it? The analysts. The analysts are going to do it. Okay. So it's a beautiful connection. I hope it stays with all of us. All right. So now moving on. So first thing is, let's understand what is data. Okay. So then we can talk about data mining or a particular small part of it, which is known as data clustering. Okay. So now this is one of the ways in which you can represent the data, and this is a very familiar way. All of us have used Excel and we have entered data for so many things. All right. So this is one particular representation. Don't presume that this is how a data will always look like. No. Okay. This is one particular representation of a data. Okay. If you look at it here, each row that we are talking about is one particular observation. All right. That is in the language of data mining, this is one particular data point. Okay, you're looking at a data point. All right. So each row, if you look at it, that is an entry that you have. That is your data points. All right. So each entry that you have, for each one of them, you have various values that you're going to enter. That is, those are the columns. And these columns, we're going to call them as variables. These are some variable is very familiar to mathematicians. All right. So all the columns are the variables, and then along the rows you have what are known as data points. All right. So the variables have another name in data mining. It's also known as attributes or features. All right. You call them as attributes or features, right? So this is one particular representation of a collection of data points. All right. So these are some terminology that all of us should understand. This is a whole collection. This is just a sample of the collection that has been shown here. Okay, I hope I've made myself clear. So each row that you have here is a data point, and every column that you have here, in the language of mathematics, I told you it's a variable. And in the language of data mining, it is known as attributes or features. All right. I left out the last one. Okay, that is the fruit. Okay. Now, basically, if you look at this particular thing, you'll easily understand that what am I trying to do? Okay. I'm taking a fruit. Assume that I don't know the fruit. I don't know what fruit it is. Okay. I assume I do not know. Based on the features. Okay. Based on the color of the fruit, the weight of the fruit, the shape of the fruit, and probably the price. I do not know what price is this. Okay, so I don't think you can get any. It is not an Indian currency, obviously. All right. So based on all this, I'm able to identify what kind of a fruit it is. Okay. So this I would like all of you to note down that based on the features, I'm trying to identify. In the language of data mining, identification is known as classification. I'm trying to classify. I'm trying to group. Okay. In biology, you have right from the beginning. Okay. How do we segregate the groups? All right. This is a mammal. This is an animal. Okay. This is a bird. Okay. Based on the features, we segregate them. Okay. That is basically the class. You have the mammals. You have the animals. You have then you have the birds. You have the reptiles. So okay, those are the different classes. Okay. So here, fruit is the thing that we are trying to do, and you're trying to find out what kind of a fruit. All right. So I hope I made myself clear. It looks very simple. Okay, but this is the base that we are going to use. All right. So you have different data points, and then you have the various variables that we have there. All right. So depending on, so if it is red, weight is so much, and it is round in shape, price is approximately this. Okay, it is a melon. All right. So if it is yellow, the weight, I've come here now. So if it is yellow and the weight is 25, it is oval in shape and price is so much, it is a pineapple. Okay, what are you basically trying to do? You're looking at the features and you're trying to classify it. Okay, you're giving it a label. Okay, please take note of these terminologies. You're giving it a label. If, okay, you can look at it. Okay, see, not always. The first entry that we have here says that it's red in color, its weight is so much, brown, price is this much, it's a melon. The next one is also, okay, because when you talk about shape, you can't really say that, okay, oval may be sort of round, okay. So so you have to look at the various variable entries that you're having here. So this is something that we have from the existing knowledge. You're trying to classify them and group them. But my sole idea of presenting this is to show you that this is one representation of a data where this is a very nice representation where we have the, along the rows, you have your the data points given, and along the columns, you're going to have the features and the feature values given. All right. So I'll move on. Okay. So now the basic terminology already I've introduced in the previous slide. Okay. So it goes like you're going to have a value for a particular variable. So in the previous example, we had shape, price, color, and so on. Okay. Here I'm just giving you gender could be one variable. Okay. Even in your school or in your college database, when you're entering the details of every student, okay, you'll have the student name, you have the register number, you'll find out the gender. All right. And then probably age, all these things, right? So you'll have gender, you'll have age, all those things are included in. If I'm talking about a particular student, I need details about all this. So there are variables called gender, and the gender can take the variable gender, or in the language of data mining, it is known as attribute or feature. This can take male, female, and other. Okay. So you can take, I've just given male, female here, even the other gender can be included here. Okay, so gender can take values male, female, right? So this is what I mean by value of the variable. And then if I'm talking about age, it can start from even right from birth. Okay, I can say it as not one can correspond to day 1 to 120 can be years. Okay, so just talking about a value for the age, right? So what is actually happening? If I'm taking a particular data point, I have to measure the values of the variable for a particular observation. If I'm going back to the student database. If I look at the student database, I need to have the student name, probably the different first name, last name. Okay, then I'm going to have the register number. Then I'm going to have the date of birth, father's name, mother's name. All these are your variables. but I need the values. Okay, that is what I mean by measuring the values. For example, if it is my name, it will be Kalyani, first name Desikan, then it will come to my register number and so on. So you need to measure it. So data is measured. Already I've introduced this particular terminology to you, which is data point. All right. So data point is I take a single example, okay, a single row. From the previous slide, you can think of it as a single row. And in that single row, what are the different values that I have? So again, it's mentioned here, it's a single row in a file of data. Again, I'm stressing this is not the only way to represent the data, but this is the easiest way that you can think of the data. Right. So moving on. So again, in a tabular format, I want you to appreciate that if I'm talking about data, I'm working about data, I should know the types of data. Okay. So, so for that, so it is basically, I told you another name for variable is attribute. It's an attribute vector data, right? So here, if I'm looking, it is a concise version of the table that I'm having here. So each row that we have here is a data point. And obviously from the thing, from the column title, you'll know that A1, A2 are all the variables that you're talking about. You can have any number of variables, all right? And ultimately, like in the table that I showed you initially, you had fruit, we had a classification. Here, the class is denoted with a C, okay? So you have an attribute vector data coming up here. And the data types, you have different types of data. May I request you to mute, please? And a hand is raised. Can I take the questions later?
Yes, ma'am.
Okay, there's a hand is raised. Okay, probably by mistake. All right, fine.
Okay.
So there are different data types. One is known as the numeric data type. The other one is categorical data type. Category is nothing but grouping. Okay. For example, if you take your again going back to this the college database, right? Gender is only category, right? Groups, male, female, other. Okay. So that is category. Other than in contrast to that, if I look at age is a number, numeric. Okay. So you have different types of data that we have there. And the data will not always be static. You can have dynamic data also. I'm not going to dwell on that right now. So data need not be just the same data, right? It can evolve over time. Okay. For example, if you're getting radar data or you're getting data from my own subject, okay, from the cosmos, if you're getting data, okay, continuously the light is being streamed. All right. So dynamically it will keep changing, right? So, and always I've been stressing again and again for the past 5 minutes that the table form is not the only form of data. Okay, there are other forms as well. You have text, you have web data, and if you have talking about metadata, okay, this is a huge thing. Images and audio and video. Right now, audio is being recorded, video is being recorded, images are there. All of us are on Snapchat, Instagram, things like that. Images are being exchanged. All right. So there are other data forms as well. But the easiest one that we can understand is putting it in the table form. Okay. So I would want you to appreciate that data can be of different types, numeric, categorical. There can be in other forms as well, not just as a table. It can be as a text. All right. Every email is a data. Okay. Everything which is there on the web, all the web pages which are there, that is a form of data, right? All the images, all the audio, video, everything is data. Okay, I just want the youngsters to understand that data is of different forms. All right. So now moving on. Okay. So this I already mentioned a little bit, but I'm not going to dwell on this particular slide. Okay. So first I said the raw form of data is obtained, and then you need to do something known as data cleaning. There are various ways to do it. I'm not going to again get into that right now. Then you do something known as data integration. Then you do a data transformation. That is important. All right. So I'll just stop here a little bit. See, when I'm talking about this data cleaning, lot of statistics comes into play. All right. So as a mathematician, we have a very big role. All right. A lot of statistics comes into play in data cleaning. Again, when it comes to data transformation, okay, a whole lot of linear algebra comes into play. I want the youngsters to take note of these things. Okay, so where are we using the statistics? Okay, for statistical analysis and again things like data mining, you're going to use it. All right, and one more thing is in data reduction. Here also you're going to make use of linear algebra in a very big way. All right. So I hope we understand how important mathematics plays a role in all these things. And definitely to do data discretization. Okay. You're having continuous stream of data, but if I'm not able to work with the entire thing, I can discretize it, take it at this time point, next time point, and so on. Okay, then it becomes one after the other, then I can start working with it. So these are the main tasks in data pre-processing. I hope we remember the knowledge discovery slide that I showed in the beginning. All right. So the data pre-processing, all these tasks are involved. May I request all of you to kindly mute, please? If the host can mute everybody other than me, can it be done, please? It's okay. I'll move on, please. All right. Okay, I've unmuted myself. All right, I'll continue. So these are the major data pre-processing tasks that we have there. One minute, I don't know, my slides is not moving. Yeah, I think I lost control. Right. Okay, so these are the major tasks of data pre-processing. Again, the next slide also shows the data pre-processing in a nice form. I would want to draw your attention to these things. Already I told you about the data cleaning and data integration, data transformation. See, the original data set is like this. I do some kind of normalization. Okay, I make use of statistical techniques to do the normalization to get the data to this particular form, and it becomes more manageable. Okay, and then data reduction, of course, that's very, very important because huge amount of data is there, but we may not require the entire set of data, right? Now, this particular table, I would like to draw your attention to this. So here, if you can see it, it shows up to 2000 entries are there, which means I'm having 2000 data points, and I'm having, if you've understood the jargon till now, you have 120 features which are there. Okay, so A1, A2, up to so many features are there, right? So now what can be done is making use of the data reduction techniques, for which you can make use of statistical techniques or linear algebra, predominantly linear algebra. You can make use of that to reduce, okay? You can reduce the number of data points that you're considering, that can be done, or you reduce the number of attributes that you're going to take into consideration. Not all the attributes, not all the variables are going to be important. Okay, so I can give you a quick example. Probably, sometimes we do that. We ask the person to enter the date of birth. Okay, and after some time we may ask the age also. It happens when we are creating forms. Okay, sometimes it happens that you ask them for the date of birth. You also ask for the age. Okay, but I think the age attribute is redundant. You don't need it. Okay, because if you know the date of birth, obviously you can compute the age, right? So it is not going to be as simple as what I'm trying to say now. All right, you can make use of techniques to do a data reduction. So when you're talking about data reduction, either I reduce the number of data points that I take into consideration, or I reduce the number of attributes. Okay, either of these things can be done, or both of these can be done depending on the problem on hand. Okay, so these are the main things. So we have done with pre-processing. Now, after pre-processing, so we got the data, we have cleaned the data. Now we are going to move on to the data. We have done the data transformation also. So got the data, we have cleaned the data, we have transformed the data. Now we are going to move on to the real data mining tasks. All right. So I would just mention two of the key data mining tasks that we have there. One is known as the classification task. The other one is known as a clustering. Okay. So these are two different tasks which are very, very predominant in data mining. You have other things as well, like associated rule mining. Okay, there are so many things which are there as part of machine learning or data mining. All right. So when I'm talking about classification, I already gave you a glimpse of it when we saw the original table of the different variables or the attributes of the fruits. And based on these attributes, you either classify it as a melon or a pineapple or an apple. Okay, so you're classifying it or you're putting it into a group. Okay, so classification, what happens is upfront, I'm just giving you in a nutshell. When I'm talking about classification, upfront, I have some data which is given to me. And in that particular data, the class labels, I hope we remember the last column was the class label. Okay, in the general table, I indicated with a C, right? In the fruit table, it was indicated by the name fruit, right? So that was the class. The class label is also given. So we start off with a known data set. And so since we're starting off with a known data set, under our knowledge, we are going to do the remaining task. All right. So here the word learning refers to your the model. Okay, the algorithm that you're going to come up with. Learning is not the learning that we're talking about in teaching learning. Here, when I'm talking about learning, we're talking about the model that is involved. Okay, so since we already know the class, so under that particular supervision, you're doing it. So this kind of a thing is known as supervised learning. All right. So I'm not going to go more into supervised learning because my topic is clustering. I want you to have a feel for why clustering. All right. So now, when you come to this unsupervised learning, you know that under supervised learning, you already have an existing task. Okay, you have an existing data set, and the existing data set has a class label, has one of the entries which is given. So I already know what is my class label. All right. So now, by the very name, you know that supervised means the class label is going to be there. If it is unsupervised, I'm not going to have the class label. Okay, so that's a very simple way of understanding what it is. Okay, but what does clustering do? Okay, so if you look at it, so what happens in clustering is class labels are unknown, as I already told you, and you have a given set of measurements. Okay, observations are there. That's it. I don't know the class label. So what am I going to do? I am going to cluster it. I'm going to group it. Okay, so that is the main role of clustering. I do not know the data. I don't know. I just have the variables and I have the values for the variables for my various data points. And based on that, I do not have the class label known upfront. All that I do is with this, I'm trying to group it. Okay, but I have the variables. Okay, I can find out a pattern. I can find out a connection between my variables. So that is the main logic behind clustering. I'm going to group it. I'm going to cluster it. Right. So moving on to clustering. So if you look at it, so basically clustering is going to divide the data into groups. Okay, you're going to cluster it or group the data. Okay, so how will I group it? Okay, if I'm talking about a particular, if I ask a class of students to group themselves, obviously they will group themselves into their friends. All right, so so that is the grouping that we're talking. So points in any one group are more similar. Okay, which means that people with similar likings, similar tastes, obviously they are the friends, they will group together. Okay, that's a very simple example of a cluster, a group. All right, so points in one group are more similar compared to points which are outside the group. All right, so probably if you take your own college, Mahalashmi College, you are all similar. You are okay against the other people. Fine, so that is the grouping that we are talking about. Okay, now the picture which is given here is something that I really like. All right. So if you look at it, there are four people here. You have Collins, Vetter, Lander, and Peter, right? So if you look at it, if you look at Collins, he is a biologist. Okay, if you look at the slide, he is a biologist. Basically, he's a biologist, but he works in a company called HGP. All right, I hope it's clear. Okay, if you take Venter, okay, he's also a biologist, but he works in a different group called Celera. All right. Again, there's a similar kind of a thing. These two people, Lander and Peter, okay, they are mathematicians. Okay. Now, if I'm talking about similar groups, you can ask, how do you want the group? Do you want to group the biologists together, the separate based on their subject knowledge, group biologists, group mathematician, or do you want to group them based on the companies where they are working, the organizations to which they belong? Okay, how do you want it to happen, right? So again, this is what we're trying to say. What do we want? What are we looking for, right? So based on that only, you should start clustering. Based on that only, you should start forming the groups, right? So if I want to group them purely in terms of the subject knowledge, I would put Collins and Venter together because they are biologists, all right? And the other two people as mathematicians because their subject knowledge is mathematics. I'll be grouping them together, right? I hope I made myself clear here. So grouping is important, but people in a group are similar. When I talk about similarity, it differs, okay? What is the similarity that I'm looking out for? So that is very, very important. So in data clustering, the concept of similarity is very important. What do I mean by similar? Okay, so again, this slide again talks about searching for groups, the clustering. I'm not going to dwell on this particular slide. Okay, basically you are searching for groups or clusters of data points. Okay, so in a particular group, all the points are similar to one another. If I take one group, they'll all be similar. If I take a basket of oranges, all the oranges would look more or less similar. Okay, if I take a basket of apples, they will look more or less similar. Slight difference in color and shape can be there, but by looking at it, you know that that is going to be an apple or a orange. Okay, so groups or data points in a particular group are going to be similar. Okay, so that again, see, data mining is not just grouping simple things. It has a lot of applications. Basically, from a marketing perspective, you can group similar customers, you can group similar products and the way they behave. You can model all these things. Okay, it's got wide scope, right? Okay, so moving on. So you're going to group things together, right? Again, I've come back to that. So when I'm talking about a cluster, I'm talking about a group, all right? The key thing that we need to consider is within a cluster, the distance that I'm going to look at. Okay, distance means how close they are. Okay, that closeness or opposite of closeness is distance, right? So you can take them as, I can call it as similar, dissimilar. Okay, and okay, so the terminology is going to be interchangeable. You can call it as distance. Okay, you can call it as dissimilarity, or you can call it the opposite of distance as similar. Okay, these terminologies keep changing in data mining, right? Okay, so what will happen? You would expect the points, data points within a cluster, okay, to be very close to each other. Whereas if I look at clusters which are different clusters, the distance between the clusters have to be huge. Okay, so that is what I would be looking at, right? And if I look at clustering, clustering as such has applications. You can use it as a tool. Okay, if I do not know the class labels, I do not know the grouping, just the data point is given and I just group it based on some similarity. I'll come to that. Some similarity measure that I'm looking out for, some similarity measure that I'm looking out for. Based on that, I'm grouping my data. So the pattern is identified and I've come up with my clusters. I have come up with my groups. After coming up with a group, I can give it a name. I can give it a label. All right. So after you label it, you can use it for a classification task. All right. So you can use it as a standalone tool, or you can use it as a pre-processing steps for, say, classification. First, I do not know anything about the data. I collect the data. I do a clustering on it. I group the data. After grouping the data, I give the different groups different names. And then having given the names, now I'm ready for classification. I can take it to the next level. Okay. Even that way, clustering can be used. Right. Okay. So this is a very simple way of looking at clustering. Okay. So if you look at it, you have raw data, and then you apply some clustering algorithm. At the end of it, you're going to have clusters of data. Okay. So if I'm given this set of logs that we have there, you can group them, and obvious. Okay. For human eye also, it's very simple to look at it the way we have grouped them. All right. Probably instead of here, I've grouped them as 1, 2, 3 groups, or in the language of data clustering, we have grouped them into 3 clusters. All right, there are 3 clusters that we have there, and that's what has been done here. Probably I needn't have done this. Okay, I could have just grouped it into 2. Okay, just based on color, if I'm going to group it, okay, I'm going to have just 2 clusters, the yellow ones and the green ones. Okay, so again, I'm stressing on the point that first you have to decide what do you mean by similar. Okay, here they've taken both color and shape of the lock handle as the criteria. But if I don't consider the lock handle or the size, all right, if I just look at the color of the locks, I can just group it into two. Okay, so the similarity that I'm looking out for varies from domain to domain. So based on that, you're going to decide on the number of clusters. All right, I'm stressing on a few things, the number of clusters and things like that, because these are purely mathematical aspects and there's a huge scope available for research here. And a few of my scholars are working on these things. All right. So, so I hope you understand what I mean by clustering, right? So definition, I don't think I will stress on it, but nevertheless, I will just quickly tell you that, right? So you're going to have data points, right? The data points in one cluster are more similar, all right? And data points in separate clusters, okay, they are less similar, okay? So this much, if people understand, it will be very nice for the young audience which I have here, all right? So the first slide, from the first few slides, you understood what is data mining. Now, if somebody is asking you what is data clustering, you can say that it is grouping of data, and data is grouped in such a way that the data points which are there in one cluster are more similar in some way. Data points in other cluster are, different clusters are, they are less similar to each other. Okay, so we keep using the term similar, similar, similar. Okay, so the concept of similarity measure is very important. Okay, so we have to take into consideration the concept of the similarity measure that we have there, right? If I'm purely looking at it as numbers, okay, as a data point, okay, as mathematicians, all of us know what I mean by a point. Okay, in 2 dimension, I just have x-axis and the y-axis, and I have a point plotted there. All right, like that. Okay, instead of 2 dimension, here we are not talking even about 3 dimension, I'm talking about n dimension. We cannot imagine it, but you can still think of it as a point in some dimension, right? So if in a school, if your the teacher asked between 2 points, how would you find the shortest distance? All right, so for one particular point, the value would be x1, y1. For the other point, it will be x2, y2. Okay, I'm talking about a 2-dimensional plotting of points. So one point I pick up, its coordinates are x1, y1. I pick another point, its coordinates are x2, y2. All right, if I want to know the distance points, what do? I use the Euclidean distance measure. All right, so that's a very simple measure to use. The same Euclidean measure can be used in data clustering also, but only thing is you will not be working with just x1, y1, x2, y2. Okay, so not just 2 data points, you will have some thousands of data points, and for each of these data points, you will not just have x1, y1. Okay, it will be for one data point, I can call it as x1, x2 up to xn. The other one can be y1, y2, whatever. Okay, so 2 different data points with n attributes. Okay, n axis. You can think of it as a data point on n axis. All right, so different data points you can think of. Even there, you can find the Euclidean distance. Okay, this is a very famous distance that is used, a measure that is used. So whatever you have, okay, but the only catch here is if you're using the Euclidean distance, okay, you assume in mathematics, you assume the variables to be continuous, all right, and then the values have to be numerical. Okay, I think I already told you the different types of data that we have there, numerical data, categorical data, and things like that. For categorical data, we can't use the Euclidean distance, but if I'm talking about numbers, okay, like if I'm plotting on a 2-dimensional graph, okay, the first point can be at 1, 2, the other one can be at 3, 4. All right, so I can plot it, okay, and then take the distance between the points. All right, so similar thing can be done, but if it is not numbers, so the only thing is if you're using a Euclidean distance measure, all the variables that you have, okay, variables you know that are along the columns and the data points are along the rows. So you have the variables, they have to be numeric, or you convert the categorical variable to a numeric variable, then you can apply your Euclidean distance. But if that is not possible, okay, obviously you cannot work with just numbers, okay, there would be some problem specific measures. I'm just exposing you, this talk is just an introduction to data clustering. So I just want you to be comfortable with the terminology. Okay, so this is one application. I'm not going to dwell on it, probably it'll get elongated if I go on to that. All right, so you can use it in market segmentation, right? So people from other backgrounds can appreciate that clustering, data clustering, it's not specific only to computer science or mathematics. Even if I want to do a market segmentation, I can do it. Okay, so I can collect the various attributes pertaining to the customers. All right, we can collect the data for the various attributes of the customers, and then all the information that can be obtained, and then you're going to group the customers based on some similarity measure. Okay, and based on, and so that would be a very nice market segmentation, which is very important, right? If I want to have a marketing mix, okay, and have my products moving. Okay, so this is one such application that we have. And the other one is document clustering. Our research group also works on document clustering. Okay, so basically, many of us do web search, all right? How is it that the moment you type in less than fraction of a second, the document is retrieved for you? Okay, for that, the documents have to be tagged properly. They need to be grouped properly, or rather clustered properly. Okay, all that is done for us. What we're just seeing is in Google, we just enter the search term and we are getting the documents being retrieved for us. Okay, but the document clustering, along with you need to have the search engine optimization working in tandem, working together, so that you can retrieve information. Okay, you can do information retrieval. Okay, I think I moved. Okay, so you can do information retrieval. That's something beautiful. Okay, so our group also works on document clustering, how to group documents. All right, how to identify if two documents are similar. Okay, those of us who are in research, we know about the plagiarism check. Okay, there is a sanity check. We do plagiarism check. So for the plagiarism check, obviously, if I'm going to check if two documents are exactly copied from somewhere, okay, I should be able to compare it. All right, I should be able to tell that these two documents are similar. All right, for that we make use of document clustering. Okay, it's a beautiful technique. And not only document clustering, you can combine all the tweets which are there. You can do some analysis based on the tweets which are collected. For the more learned audience, what I'm talking may be very trivial, but for youngsters, please try to grasp a few things so that you can explore a lot of these things on your own. Okay, here I've given you just 2 examples. All right, again, I'm coming back to this. So the key important thing in clustering, if you look at it, is the distance. All right, so it's a distance between points. When I say points, it is data points. All right, so the key thing that we're going to look at is the distance between data points. And you have major approaches, already told you. One is the Euclidean distance. Euclidean distance is something that we have done in school. All right, so it is just x1 minus y1 the whole squared plus x2 minus y2 the whole squared. Okay, and take the square root of it. Okay, it goes on like that. Fine. So that's what you mean by Euclidean distance. But I told you that you can't use Euclidean distance at all times. You have to move on to non-Euclidean distance as well. Okay. So again, I want to drive home the fact that again, these terms are purely interchangeable. I hope we understand that. When I say distance, when I talk about similarity, when I talk about dissimilarity, okay, dissimilarity is nothing but distance. Similarity means closeness. Okay, so I need to work with these things. Okay, so the jargons that you need to understand if you're working with data clustering is, first you should know what is a data set. Data set is a collection of data points. Having known the data points, I should know what are my variables. Another name for variables are attributes and features. All right. Having known that, I should know how to check whether two things are similar or not. Two things are very close or not. Or are they far away? Are they dissimilar? Are they distant? Okay. For that, already I told you, you can make use of the distance measures. Okay. The 2 distance measures which I mentioned were the Euclidean and non-Euclidean. There are so many, plenty of them which are there. You could make use of to find out whether data points are close to each other or not, because the sole aim of data clustering is to group the data points into groups such that points which are there within a group are very similar opposed to the points which are there in other clusters, and the distance between the clusters is maximized. All right, so that is the sole aim. Again, I'm coming back to the distance measure, right? So if if you can have a look at it, if you are with a mathematics background, you will appreciate this particular formula, which is known as the Minkowski's distance. This is the generalized formula, right? So basically, if you look at it, you're going to have, basically, you're going to have, say, here what is given is 2 data points are considered. Just a minute, I lost my mouse. Okay, so this Minkowski distance is something very, very well known to mathematicians. All right, so I'm taking 2 data points. Okay, so two data points which are there, and this is the first data point. This is the second data point. Okay, so xi, xj, if you're calling it as capital Xi, xj. Okay, and each data point has p dimensions or attributes or variables. Okay, so we have to grow from a 2-dimensional perspective. Okay, it has to go to a p-dimensional or n-dimensional, whatever you want to look at. All right, so you're going to look at a p-dimensional data point that you're going to have there, right? So this is basically the higher version of the Euclidean distance. So instead of 2 that we had there in Euclidean distance, here you have q, which is a more generalized formula, which is the Minkowski distance, right? So if I'm going to put q is equal to 1 in the previous formula, we get what is known as the Manhattan distance. And if I put q is equal to 2, we get what is known as the Euclidean distance. All right. So this is one way of computing the distance between 2 data points. All right. So based on the distance, we are going to group them. Fine. So again, this is the same thing with a different name. Okay. So this Manhattan distance is also known in the mathematics language. Manhattan distance is also known as the L1 norm, and the Euclidean distance is known as the L2 norm. All right, so this is to show that whatever you're learning in mathematics has a lot of role to play in so many fields. Okay, especially data mining, data clustering, there's a lot of role to play. Moving on, so this is just a simple representation. Don't think it's going to be that simple to do it. Okay, but this is a 3-dimensional representation. Okay. So you obviously what's going to happen here, what is shown here is one cluster here, there is another cluster out here, and there is a third cluster out here. All right. So based on some grouping, it is obvious from our naked eye, you can find out if I have my points plotted, I can easily see that this is how the grouping is going to be. All right. But it's not going to be that simple in real life. It's not easily, the clusters may not be discernible to our, just by looking at it, you cannot do it. All right. So this is one of the key features of data clustering. What should happen? Inter-cluster, I mean, first we'll look at intra-cluster. Intra-cluster means within the cluster. Within the cluster, my distances should be less, which means in the language of optimization, the distance should be minimized. All right. So if I take all these data points, the distance between them is minimized. All right. So if I look at this, they're all close to each other. Okay, again, the distance measure is coming into play. But if I look at the distance between the clusters, if I look at the distance between this cluster and this cluster, this one and this, that is far apart. Okay, so that is how we are going to identify the clusters. Okay, so this is a beautiful concept from optimization, which is used in clustering. Okay, so you have to mainly understand that clustering works on minimizing intra-cluster distances and maximizing intercluster. When I say intercluster, it is between the clusters, the distances have to be maximized, but within the clusters, the distances have to be minimized. Right. Okay. So again, these are some examples. You can make a note of it. All right. So there's something known as Jaccard distance, cosine distance, edit distance. These are all various distance measures. And again, as I told you with the log example, okay, it depends on how we want to group. So depending on our problem on hand, we have to choose the distance measure. Depending on that only, we have to choose our similarity measure. I'm using all the terms so that we get used to the fact that when I say distance or dissimilarity or similarity, I'm referring to the same concept, trying to find whether things are close to each other or they are far away from each other. Right. So these are different clustering approaches which are available. Right. I already mentioned 2 the beginning slides. You have partitional approach, you have the hierarchical approach, then you have the density-based approach, grid-based approach, model-based, and so on, right? So, so many approaches are there, but the most popular ones are the partitioning approach or you can even call it as partitional approach and the hierarchical approach. All right. So these are certain approaches that you can use to cluster. Okay. So the different things are there. And the one that I was talking to you about initially is the k-means method or k-means algorithm for doing the clustering of data points. Okay. So, I'm not going to touch upon the different approaches, just that we should know that these approaches are available. Okay, right. Request to the organizers, if I'm exceeding my time or nearing my time, please flag me. I'm not able to see the time. So if I'm nearing my time, I request you to flag me. Okay, so please tell me that you're reaching your time. Am I okay? The organizers can tell me that, ma'am, you've reached the time. Okay, so I'm not keeping track of the time. So you can flag me when it is close to 3:50 or something, you can tell me. Okay.
Yes, ma'am.
Okay, fine. I'll continue now. So I hope the story is clear so far, right? So we have data and we are looking at data mining, and within data mining, a very small aspect called data clustering. And when I'm talking about data cluster, what are we talking about? Is grouping of data points and the different terminologies. I hope the youngsters are comfortable with it. Okay, so we are talking about data points, we're talking about variables, we're talking about attributes. Okay, variables, attribute, features, they all mean the same. You have data points, you're going to group the data points. How are you going to group the data points? You're going to make use of distance measure or similarity measure. Okay, and there are various approaches to do data clustering, and take you through is the k-means algorithm. Okay, so this is a partitional based algorithm. I think initially I mentioned that I'm going to touch upon. Basically, our research group works only on partitioning algorithms or partitional based algorithms. Okay, so basically what you're going to do is you're given a database. You have a database or data set of n objects or n data points. You can call them as objects or you can call them as data points. You have a database D which has n objects, and we are going to group them into k clusters. Okay, again going back to the lock example, they were grouped into 3 clusters. All right, you could have grouped them as even 2 clusters, which I already mentioned. So the sole idea here is, so if you just from that particular example, you know that the k that we are talking about, okay, the number of clusters, okay, the k that is indicated here, k is very important. Okay, it all depends on the user. What do you want? Okay, again, sorry for repeating, but going back to the lock example, if I wanted just 2 groupings, my k is 2. If I wanted 3 groupings, my k is 3. Right? So it depends on the user as to decide on the number of k. Okay, but there comes the problem. Okay, I'm giving you some open issues. If there are some researchers who are interested in this kind of a work, okay, you can look into it. Okay, so the k-means algorithm, okay, or the k-medoids algorithm, both of them, okay, they have a very big drawback in the sense that the k that we are talking about has to be given in an algorithm. You need to tell, I mean, the log case or separating fruits and things like that, and there are limited number, you can do it. But in this age of big data, you can't sit and see some millions and millions of data. You can't keep running through it. All right, the algorithm should do it. Okay, so the main issue in the k-means algorithm. All right, so but one more thing before coming to that, let me draw your attention to the k-means algorithm. It is such a popular algorithm, the k-means algorithm, but it is also known as the McQueen's algorithm. In statistics, you would have come across this. All right, but look at the year. It was given way back in 1967. Okay, and to this day we use that particular algorithm, right? The k-means algorithm, which is used for grouping, which is used for clustering, it was developed way back in 1967. All right, so the point I'm trying to drive home is it's a very simple approach. You're trying to partition. When I say partitioning, you're trying to split it, group it into different clusters. All right, but how many clusters the user has to tell? Okay, the k that we are talking about, number of clusters, the user has to specify. All right, if that is the case, there is a lot of research which is going on, because how to define, when I say user define, it's for small sets, but otherwise my algorithm should tell me that Okay, this is the beautiful, this is the K that will work out for you. Okay, so since it is based on the algorithm or the model that you're developing, this is a very, very, very rich research area. How to determine the K, how to determine the optimal number of clusters given a particular data set. Okay, that is, a lot of research has been happening. Still there is research open. Okay, people are still playing around with it. Okay, so K means algorithm. There is another one also known as K-Medoid's algorithm. Okay, so a quick difference between these two is, by the name means, okay, we know that you're talking about statistics, you're talking about the mean value or the average value. Okay, you take a group, okay, you find the mean of those particular set of data points. Okay, you know how to do it. You have some 10 data points, sum it up, divided by 2. Simple, from having only single entries. All right, just add it up and divide it by 10. From having only one values such as 1, 2, 3, 4, 1, 4, 5, 6, 10 values are there. I just add it and divide by 10. I'm going to get the means. Okay, it's not going to be that simple. Remember, when I say values, you're going to look at all the dimensions. Okay, the entire variable set that you have there. And right now, if you're looking at big data, you can have the columns, the variables itself going into thousands, okay, or lakhs perhaps sometimes. And your data points can run into trillions or more than that, okay. So when I talk about K-means, it works on the mean value, okay. So this is to know the terminologies, okay. This is a very brief session, so I want to highlight the key terms here. So means refers to the average statistical mean that you're talking about, the average, okay. So K refers to the number of clusters, and here the entire thing works around finding the mean value of a set of data points. Now, opposed to that, you have what is known as the K-Medoids. K-Medoids was given in the year 1987, okay. So that works around, if I'm taking about different groups, okay, how to group them is, there'll be like a leader and you're going to group around it based on the similarity, okay. So in K-Medoids, we take one of the people within the cluster as a representative point and we do the grouping. Whereas in K-means, we take a group, we take the average and you're going to group around that. Okay, that is the main difference. I'm not getting into it, but you should know that such things are existing. Right. Okay. So hierarchical clustering is another thing. I'm not getting into that. I will tell you one main difference between partitional and hierarchical. In partitional clustering, the entire data set is given, and then you break it down into smaller and smaller groups. You try to group it, okay? You try to bring similar things together. The full data set is given, and then you start breaking it up into smaller and smaller. That is what you mean by partitioning. In hierarchical, what happens is, you take each data point as individual clusters. So if I'm having A, B, C, D, E, A is on itself one cluster, B is a separate cluster, C is a different cluster, and so on, right? I start off with how many ever data points you have, that many clusters, and then I start looking at it. Okay, this cluster is similar to this cluster, bring them together. So if you look at partition approach, it is a top-down. Okay, this is a bottom-up. That's the main difference between hierarchical and partitional approach. Right. So K-means algorithm looks like a very, 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 very simple algorithm. It is. All right. So it is a simple algorithm. Still, there are a lot of issues out there. You're going to every cluster. When I say cluster, it's a group. It is all centering around a centroid. When I say centroid, it is nothing but the mean, the center of the group, the average of the group that we are talking about. So each cluster is associated with the mean. This is associated with the centroid. Okay, and every point is going to be assigned or you allot it. Okay, right? Like in class, you form the different groups. First, you have a leader, and probably you assign people to that. Okay, or if you give a student, you ask a student to form the group with that person as a reference, the others join the group. Okay, so that would be a better example. Supposing I say yes, okay, Krishnaveni ma'am is a leader. All right. So with that, with Krishnaveni there as a leader, then others will join. Okay. So depending on the closeness, similarity, how well I gel, I can form a cluster. So it is all dependent on the center that I choose. All right. And how close we are. So if I'm looking at it, each point is assigned to a cluster, okay, to which it is close. And the number of clusters also needs to be specified. This is a very big issue. Again, I'm stressing on it. So the algorithm, this is all. This, if I'm looking at the k-means algorithm, it is just this much only, right? I'll just tell you the algorithm. I'll take you to an example very quickly. Among the set of data points that I have, I choose arbitrarily k points. Okay, in a class of say 60 students, I just pick arbitrarily 6 people. All right. So which means that I want 6 groups. I have 6 leaders assigned. I want 6 groups. So arbitrarily, I'm choosing k points. In our example, which I told you, we are choosing 6 group leaders. All right. So having chosen the leaders, the groups are formed. Okay. So first I have to decide how many I want, how many groups I want, and what are the points. Okay. So whom I choose as a point, I mean, and the class example will not hold here. In a data set per se, supposing I'm having 1000 data points and I want to form 10 clusters, arbitrarily I choose 10 points because I want to form 10 clusters. There are 1000 data points, but I want 10 groupings. All right. So I arbitrarily pick 10 data points. Are we okay? So we pick 10 data points, but that arbitrarily picking is an issue here. Okay. So I'm just pointing out the issues. Again, I'm telling you this is the time is short, but I wanted to give you an overview. Okay. The first thing is specifying k is a very difficult thing. The next thing is how to choose the k different points initially. Okay. That is one more thing our research group is working on. Choosing the k, it affects. Okay. Because if you look at it, I mentioned 2 things. You have to minimize your intra-cluster distances and maximize the inter-cluster distance. All right. To do this, it's basically an optimization problem, right? If I don't choose my initial points correctly, okay, if I don't choose my initial centroids correctly, if I don't choose my initial mean values correctly, well, not mean values, initial points correctly, if I don't do that, then the clusters will be formed, but in mathematics, people will know that it will be a suboptimal cluster. Okay, it will not be the cluster that is going to be the ideal cluster or the optimal cluster. Okay, so there are real open issues in data clustering. One thing is the value of k that you need to specify. The other one is the initial points that you choose to do it. Okay, so I'll move on quickly. I hope I still have time. All right. Yes, another 2-3 minutes. I'll just take you through. I'm not going to stress on this. Just look at this example. Okay. So, right. Okay. So this is the initial starting point that we have. You have, you can see this is the starting point that we have here. All right. So this is the start that we are having. Okay. So you have the points. This is a 2-dimensional representation. You have the points being plotted here. All right. So now upfront in this particular example, we've told that the number of clusters that we are going to form is 2. Okay. But who told you 2? Doesn't matter. I'm starting off with 2. All right. Now, these red points that you see, are the ones that you have here and here. These red points are nothing but the 2 seed points or the 2 centroids that we are choosing initially. Okay. You must be wondering, the blue ones, the light blue and the dark blue ones are the real points. Why has she chosen the red point? Okay. In K means you can choose arbitrarily any point in the domain. Okay. If I want 2 clusters, I just choose arbitrarily any 2 points within the domain. Okay. It can't be far away from the domain. From the domain, I just pick arbitrarily any 2 points. Having chosen the 2 points, I told you that it is K-means algorithm. Everything revolves around the means. Okay. Here K is 2. 2 arbitrarily initial points are selected. Now what should I do? I will take these points. Okay. I will take all these points and I start finding their distance. I take this point, find its distance from here. I take this point, find its distance. Take this point, find its distance, like that. Similarly, not only with this particular initial point, I will also find its distance from the other point. So for every point, okay, for all the points, I find its distance from the 2 initial points that we have. Okay, we find the distance and the logic is very simple. Okay, how do I group it? If if my values, if my distance of these points is obviously from the diagram itself is very obvious that these points are very close to this particular thing. So I may group these things together. At the next level, I may group this together. Okay, and these will be grouped with this because obviously these points are closer to this initial point that we have chosen. And they are slightly far away from the other thing. So the concept is closeness or similarity or distance. Okay, so distance is small, so we are going to group it here, right? So that is how the first iteration happens. So that is, so each object is assigned to its cluster. So initially no clusters are there. Then I choose the two initial points, and then based on the distance, I'm going to group it. Having grouped it, so these are the two clusters that we have, but we won't stop with it. Again, we will see whether we can improve our algorithm. Okay, we'll see whether we can improve and get better clusters, right? So now this is the first grouping that we have. This is the other grouping that we have. In this grouping, we find the average value. After this, it is the mean value. So you're going to take the mean value of these set of data points. For this cluster, you take the mean value, this mean value. So now what should you do? Again, repeat the entire procedure. Taking these two as the mean values now, you compute the distance of all the data points from these data points, from the means. All right. Now, with that, you're going to group and regroup, and finally, you're arriving at this particular last, you're going to arrive at a particular optimal solution, optimal grouping. Okay. In this case, if you see, originally the light blue point was belonging to this cluster. At the end of it, you can see that that point has moved to this particular cluster. Okay. So when will I stop? These are iterations. If you understand, these are iterations. I start, I have two values, and then I find the distance, and then I group them. I find the mean. Again, I find the distance. Again, I regroup them. Again, I find the mean and go on. But when will my iterations stop? The iterations will stop if my points, okay, there is no rearrangement or reallocation of points in two subsequent iterations. If I take, and the points are not, they don't move from one group to the other, then I stop. Okay, so you can see that lot of issues are there in k-means clustering, but in spite of that, it is working very, very fine. Okay, the main issues, if people are interested in research, you can look at how to find the optimal k. Next thing is how to choose your initial point. Okay, and then there's another bigger issue with data clustering. Is every data set clusterable? No. All right, because there's a concept of clusterability. Okay, I first need to, if for mathematicians, you will know, if I have points plotted all over uniformly, how will I group it? I can't group it unless there is a pattern. Okay, and also if I'm grouping like this, if I'm making use of Euclidean distance, there's a concept of, there should be, I mean, the moment you think of a group, we think of a circular kind of a structure. Okay, some such arrangement, a circular arrangement. Okay, not always data is arranged so beautifully. All right, so data can take different forms. It depends on the problem on hand. Okay, so this is a quick example of that. Actually, I had an illustration of step by step to do this. All right, but I do not know whether I have the time now. Okay, so probably this is just an introduction. If we can stop, we can stop, and I'll take questions because it is 3:50, I guess, right now. If you want, I will continue, but this example will take another 10 minutes. What do the organizers say? Can I stop? Because this is the overall idea. I can take questions.
Yes, ma'am, you can continue, ma'am.
Okay, can I continue? Okay.
Yes, ma'am.
Right, I'll continue with this example. Okay, so again, this is a very simple example, right? Okay, so now if you look at it, this is the data set that we are looking at, and we are having 4 medicines, A, B, C, D, right? And we are having 2 attributes, weight and pH index. These are given. What in what range these weights are and pH index, I have no clue. Okay, this is just some data set to show that. Now, what are we going to do? Our goal is to group these objects into 2 clusters, 2 groups. Okay, these are probably, sorry. Okay, I just want to find out which 2 medicines are similar. All right, so that is the grouping that we are talking about, right? So maybe they are generics. We want to group them and then finally say, okay, these two are something similar to paracetamol or something like that. Okay, I'm not worried about that. For me, it is only the data set that we are talking about. So I hope we understand. We have 4 data points here, very simple data set. We have 4 data points and we have 2 attributes. One is the weight, the other one is the pH index. Okay, it's a 2-dimensional. So 2-dimension, when I'm having 2 attributes means it is 2-dimensional data set. All right. So this we are going to plot on the 2-dimensional thing. So where we have the weight, weight along the x-axis and the pH along the y-axis. So based on that, these points are plotted. Okay, it's very obvious from our naked eye. We can say that there are only 2 groupings. All right, one grouping is here. Okay, the other grouping is here. Okay, it's very, very simple for us to do it just by looking at it. All right, but then I want you to take you through the k-means algorithm. Okay, quickly we'll go through. So what is the first step? I have to choose the initial. One second, I've lost the cursor. Okay, so I have to choose the initial points. All right, so the initial seed points, they're called as seed points, or the initial centroids, you can call them by whatever name. Okay, you're using the initial seed points. The thing is, in the previous example, the initial seed points were some points within the domain. For this particular example, I've taken the 2 of the points from within the data set itself as the initial seed points. Okay, so I'm taking A and B. The star is your seed point, initial seed point. Okay, so you know that the number of seed points is equal to the number of clusters that we are going to form. Okay, I hope we are, at least the youngsters are listening to some extent. All right. Right. So you're sitting here for more than 1.5 hours. It should be some knowledge gain. So that is the real intention behind me telling that please note these things, a few things. All right. So in this particular example, we have taken the one of the 2 of the points themselves as the initial seed points. Right. Now starts our k-means algorithm. So it is 2 groupings we want, and I've chosen the 2 initial seed points. Right. Now what should I do? I have to find the distance of all the data points. Okay. In the previous example, we had chosen 2 particular means or 2 particular centroids which were not part of the data set, and we took the distance from them. Now the data points themselves are the seed points. So we need to find out the distance of all the points from the data points, including the seed points. They are also data points. All right. So here we are having the data set given in a matrix format, and most often in data clustering, we use matrix theory to a large extent. All right. So if you look at it, you have A, B, C, D, the 4 medicinal groups that we have, and medicines that we have, and X and Y are the parameters, that is the weight parameter and the pH index that we are talking about. And these are the difference values, 1, 1, so which is this particular point A, right? 2, 1, which is nothing but the point B. Just give me a second. Sorry. Okay. So next point is 2, 1. And if you look at C, it is 4, 3, and D is 5, 4. Okay, so this is what is given in the matrix format. So this will be your X coordinate, and this is your Y coordinate. Now this is your distance matrix that we are computing. So every data point, you have to take its distance from the initial seed points that we are having, or rather from the centroids, we have to take the distance. Okay, so if I'm looking at this particular column, okay, remember that we are, it corresponds to A. Okay, it corresponds to A, and we are taking the distance of A from the 2 cluster centers. Okay, what are the cluster centers? We are calling the centers as C1 and C2. The first cluster center is A, the other cluster center or the seed point is B. Okay, so now if I'm going to look at this particular column, it is going to give me the distance. Here we are calculating only the Euclidean distance. So what is the distance of A from A? We are calculating the distance of the data point from the seed point. The distance of A from A is nothing but 0. Okay, we're talking about the same point itself. If you're talking about distance of A from the second seed point, which is my B, the distance is 1. You can see here. Okay, the distance is 1. Okay, that is only x-axis. Y-axis, they are lying at the same point. So the distance is 1. So if I'm looking at this particular column, this column is going to give me the distance of the point A from the first cluster center, and this is from the second cluster center. All right. So similarly, if I'm going to look at this particular column, okay, this is going to give me the distance of point B. Okay, this is going to be the distance of point B. Second column corresponds to point B. Distance of point B from the first cluster center and the second cluster center. What is the distance of B from A? Again, it is 1. Okay, so distance of B from A is 1. What is the distance of B from B? It is 0. All right. Now, directly, this column is highlighted. This corresponds to the distance of point D. Okay, it corresponds to the distance of point D. Point D from where? Point D from point D from the first cluster center and from the second cluster center. What is the first cluster center? It is my point A. And what is my second cluster center? It is my point B. So the distance is computed here. This is nothing but your Euclidean distance. All right. What is it? You have to, it is nothing but the x value of my D minus the x value of my first cluster center, C1. C1's values are 1, 1. Okay. And my D values are 5, 4. Okay. It's basically your Euclidean distance. So it is 5 minus 1 the whole square and plus 4 minus 1 the whole square. That is what is written here, square root of that. So that is going to give you your Euclidean distance. So that is how this 5 is computed. Similarly, you take the again for D itself, this is the distance of D. This is the distance of D from A. Okay. The second entry that you have here is the distance of D from B. Okay. So that is what is shown here. Okay. So we know that which are the two entries that we are considering. B coordinates are 2, 1. What is the D coordinates? 5, 4. All right. So you take both these things. So it is 5 minus 2 the whole square plus 4 minus 1 the whole square, square root of that. That is going to give you 4.24. Okay. So that is how we are going to have these two values coming up here. So this is how we are going to compute the distance matrix. I hope I have made myself clear. All right. So having done that, so this is only the initial step. I'll quickly go through, right? So now what should I do after I know this? Okay. Now, if you look at it, what has happened? If you look at the entries, right? Now, what should I do? I have find out the distance. I should now assign the points to the particular group. Okay. I should assign the data points to the particular cluster to which they belong. All right. If you look at this, okay. Now you can see that if I look at point C, okay, if I look at point C, its distance from the first seed point is 3.61, whereas its distance from the second seed point, which is B, is 2.83. Similarly, if you look at D, its distance from the first seed point is 5, its distance from the second seed point is 4.24. All right. So you notice that for both the points C and D, their distance to B is closer. Okay, they are closer to B. Their distance to B is smaller. Okay, so what will I do now? I will group these 3 points together. Okay, so that will be my next cluster. Okay, that is what is shown here by this the divider line, which is given there. Okay, so this is how the cluster is formed. So this, all the 3 go to 1, and this guy alone remains as a single cluster. Still, we are maintaining 2 clusters, but now the grouping has changed. Originally, we started off with the 2 seed points. Now we have grouped. Now, what should I do? I will continue my calculation. So what should I do? I will take this particular cluster. Okay, I will take, this is one single cluster. The mean of this cluster is nothing but the same value, whereas the mean, okay, the k-means, the mean of this algorithm, mean of this cluster is nothing but I need to do the x value summed up here divided by 3. And here I have the y value summed up divided by 3. Okay, so that is how I'm going to get the mean value of the new grouping that I've got there. Now, what should I do? The iteration should be continued. What should I do now? Now I have 2 seed points, 2 centroids. This is one centroid. This is the other centroid for my second iteration. Now, what will I do? Again, I will take all my data points and I will find its distance from the seed. I will find its distance from the centroid. Okay. And I will assign it to the group to which its distance is less. Okay. So this is how a very simplistic way of looking at k-means algorithm. So I move on, I do the grouping, next iteration, this is what happens. Finally, this is what happens. But this is what we originally got just by looking at it. This will be the final iteration. So these two guys are in one cluster. These two points are in one cluster, and the red ones are nothing but the mean values of this. And I already told you that how do I identify that the optimal condition has been reached? If there are no more reassignments, I take these two as my mean points now, and I find the distance, and there are no more rearrangements between the points, then I know that my optimal condition has been reached. Okay, so that's what it is. So there's the stopping criteria is given here. You will stop because no new assignment is happening. If no other new assignment is happening, I will stop the iteration. So this is how the k-means algorithm works. It's a very simple example on a two-dimensional thing. Okay, so then there's something known as how to, having formed the clusters, I should know whether the clustering is good. There are different techniques for validating my clusters. Again, this is a huge research area. Okay, one thing I already told you is how to identify what is the optimal number of k. The k-means clustering, what is the optimal number k? That is the first one. The second one is how do I choose my initial seed points? That is another big research area. Third big research area is how to identify the best optimality condition for stopping. Okay, so these are usual. So again, a quick example. Just going on how to start, and finally the iteration stops. Okay, so importance of choosing the initial centroid. I think that's the end of it. I think it was a short and a very fast session. I hope at least a few important concepts I have been able to give you. Okay, so thank you for your patience. Right, if there are any questions, shall I stop sharing and take the questions? Or you want to go to a particular slide or something like that? Are there any questions?
Anjali. Hello, Anjali.
Stop sharing. If we want, we'll get back to that.
Yes.
Any questions that is there in the chat box so I can have a look at it if there is anything?
Anjali.
Ma'am,
Any questions you please
ma'am,
share.
it seems like we don't have any questions in the chat
Okay.
box.
Okay, right.
Yes, ma'am. So
Okay.
we'll move on, ma'am.
One question somebody is saying, can you suggest best tool to handle this?
Yes.
All right. Okay, so there are so many tools which are there. Okay, and the simplest, easiest software that you can work with is the R software. Okay, R software you can use. Okay, there are clustering algorithms that you can use, and if you're good at programming, you can write your own programs and things like that. It's a huge research area. If you're truly interested, at least the PG students, if you're interested, you can have a look at it. Even those who are in the beginning stages of your research can have a look at it. Okay, how can you handle missing data? Okay, yeah, there's a missing data. It's a valid question. Okay, nice way to handle missing data. There are standard techniques, right? Okay, if I'm talking about say a numeric value, and I'm having rows and rows of values, in between one particular value is missing for a particular variable, one particular entry in that row, that column alone, that cell is missing. Okay, if that happens, all I can do is, one way of doing it is, I will take the average, the entire thing. I can fill it with the average. Okay, that is one way of handling the missing data. Filling up with the average is a very simple way, but this will work only for numeric data.
Thank you, ma'am.
Yes, ma'am. If you have any questions, or is it possible for non-mathematics students? Okay, the chat went away. 1 minute. Is it possible for non-mathematics students to enter in? Of course. Okay. It's so simple. All right. Actually, mathematics itself is not difficult. Even after entering data analysis, you will find that for a few things, you don't need to See, unless you're working on a research problem, you need not understand the whole mathematics out there. First, handle some.
Close பண்ணு.
No problem. Okay, I will definitely send my PPT to you. I'll share it with the organizers.
And there was another question, ma'am.
Yes,
What is the difference between K-means and C-means clustering we are asking, ma'am? Anita ma'am is asking.
Right, okay. K-means clustering. Okay, you work with K-means clustering if you're talking about a definitive cluster. C-means clustering comes into play when you have fuzzy clustering. And I did not touch about the fuzzy clustering at all. C-means clustering comes when you work with fuzzy clustering. Okay,
Yes.
so that is where you're going to use C-means clustering. But not ordinarily, if you're not talking about fuzzy values or anything like that, then okay, if there is no fuzziness involved, you have only crisp values, then you talk only about K-means clustering.
Okay,
Thank you,
ma'am.
ma'am.
Yes.
Thank you, ma'am. Thank you very much. It was such an insightful session and you presented so well, ma'am. I hope your lecture would have enlightened the participants by sharing your valuable illustration about data clustering in brief.
சரியா வரலன்ற. எனக்கு கரெக்ட்டா தான வந்துச்சு.
Yes, ma'am. Thank you so much.
Okay,
Thanks
ma'am.
to all the participants. Thank you for having joined this session. I hope I have given you some idea of what you mean by data clustering, and you can have a look at it. And if you want to just get into this research area, or even just for knowledge sake, if you want to do anything, you're most welcome to contact me. Okay.
Thank you, ma'am.
Okay.
Thanks for your time and effort you took to share your thoughts through this webinar.
Yes, ma'am.
And it's time to wrap up the session. May I call Dr. Mrs. K. Nyanabala ma'am to propose the vote of thanks.
Yes, ma'am. Good evening, everyone. It's my privilege to propose a vote of thanks on this occasion. First, I thank the Almighty God for gracing this successful program. Now, on behalf of Mahalashmi Women's College of Arts and Science and Department of Mathematics, I extend a heartfelt thanks to the resource person, Dr. Mrs. Kalyani Desikan Madam, for her valuable presentation with real-time explanations and the knowledge in and exploring the knowledge in data clustering in a nice manner. Thank you, ma'am. Thank you for your valuable time with us, ma'am. Now, I would like to thank the participants for your kind cooperation in this regard, and I wish to express our sincere gratitude to our management and to our principal, Dr. N. Booma ma'am, for her provoking guidance and encouragements. Thank you, ma'am. Here, I wish to thank our department head, Mrs. R. Krishnaveni ma'am, for her tireless support. Thank you, ma'am. Also, I wish to thank all my department and a big thanks to the technical supporting team. Thank you all for making the program successful one. Thank you so much.
Thank you, ma'am. Participants, kindly fill the feedback form through the link posted in the chat box. It is mandatory to fill the feedback form to get your e-certificates. Thank you, everyone. We appreciate you for being here. Thanks for your cooperation and your active participation in this national webinar. And we'll see you next time. Have a great day. Thank you.
Thank you, ma'am. Thank you so much for having me. Thank you.
Thank you.
Thank you, ma'am.